All right, so today we're going to be simplifying improving trig identities. So some strategies in order to rewrite these type of things is that we rewrite reciprocals and quotient identities. You're going to look for a Pythagorean triple. So that's what we talked about yesterday, the sine squared plus cosine squared equals 1 and that stuff. And then we're going to look if we can combine fractions with a common denominator or break them apart or if we need to factor them. So I'm going to get your identity sheet out here so I can have it. This sheet right here is the sheet I'm going to be using. So if you want to get this sheet out, you're going to use that for a bunch of stuff. I don't see the sine square yet. Right there, sine squared plus cosine squared. Okay. So my first one right here, what I'm going to do is I'm going to change them all to sines and cosines, and I do that a lot first. If there's no squares, I always change the sines and cosines first. So like down here, there's a square, so I won't do that first. So down here, secant is 1 over cosine of x minus, and I'm going to change thetas to x because I hate thetas, times sine x over cosine of x. So the bottoms are the same here because this would equal 1 over cosine of x minus sine squared of x over cosine of x. Bottoms are the same, so subtract your tops. So 1 minus sine squared of x equals cosine of x. So you need to be able to recognize that 1 minus sine squared, remember we talked about this. So if I subtract over my sine squared, I'd be left with cosine squared here. So 1 minus sine squared equals cosine squared. So cosine squared of x over cosine of x. One of those would cancel, and we're left with cosine of x. So 2, there's no squares, so I'm going to do the same thing. Switch everything to sines and cosines. So now there is only multiplication between these two terms. There's not an addition sign. See, that's addition. Don't do that. So multiplication, those two will cancel for me. So I'm left with a sine of a plus a sine of a. So that gives us 2 sine of a's. Now this one right here is just one of the properties. So if you go and look at cotangent squared, if I subtract over the cosecant, you'd subtract over the 1 and get negative 1. If you don't see that though, what I'm going to do is I'm going to change cosecant squared into cotangent squared plus 1. Either way, you're going to end up with the same answer. So we're going to get cotangent squared of u minus cotangent squared of u plus 1. Distribute your negative to both terms. So you get cotangent squared of u minus cotangent squared of u minus 1. So these will cancel. So we get negative 1, either way that we look at it. That should be plus 1. That should be negative 1. All right. So next one here. Let's see. So what I would do first on this here is that this is multiplication. So sine over cosine is really tangent. So this would be my first step here is to change this term to a tangent of x. So I'm going to have tangent of x times tangent x plus cotangent of x. Now I'm going to distribute that in. So I'm going to get tangent squared of x plus a tangent x times a cotangent of x. These are reciprocals of each other, you guys, so that becomes 1 right here. That will be a 1. So really I get tangent squared of x plus 1, and that gives me secant squared of x, because that's one of our properties on our paper right here. Tangent squared of x plus 1 is secant squared. All right. I don't know. Okay. So number 5 here. So this one is a fraction. This one's not. So I'm going to make them both fractions like this. So common denominator, multiply by cosecant x over cosecant of x. So cosecant squared of x over cosecant of x minus cotangent squared of x over. So on top now, the bottoms are the same, so you can subtract the top. So I get cosecant of squared x minus cotangent squared of x over cosecant of x. So that right here is just me doing cosecant squared minus cotangent. So that equals a 1. If you don't see it, then you can change what cosecant squared equals into the problem. But it is just going to be a 1 on top. So what I'm saying is that you can change this to 1 plus cotangent squared of x. And then you see you have a cotangent minus a cotangent. You still end up with a 1 on top. So you have 1 over cosecant of x. And this is a reciprocal here. And so you end up with The reciprocal of cosecant is sine. Right? Reciprocal of cosecant, remember, is sine. All right. So on this one, tangent, and then the stuff on bottom. So what I have found when you have stuff like this is sometimes it's easier to just flip the tangent to the bottom. You can get common denominators on the bottom and then flip it to the top. That also works. Whatever you feel most comfortable with. Looking at it real quick and seeing if I multiply the cotangent down there. And then, yeah, I think either way it's going to be fine. So I'm just going to go ahead and do the bottom, show you a different way to do it. So if I flip that to the bottom, I still end up with the same answer. So let's just I can show you how to get a common denominator for once. So this is 1 over cosine of x minus cosine of x over 1. So let's multiply to get common denominator. So cosine of x over cosine of x. So tangent's still on top. Now on bottom, I have 1 minus cosine of x minus cosine squared of x over cosine of x. Now the bottoms are the same, so you can subtract your tops. The tangent's still up there. So I have 1 minus cosine squared of x over cosine of x. So now I'm going to flip and multiply. Well, actually, what I'm going to do first is 1 minus cosine squared. So if you do 1 minus cosine squared, minus that over, you're left with a sine squared. So tangent is really a sine x over a cosine x. And then this is a sine squared over a cosine. Now we never have a fraction divided by a fraction. You flip the bottom and multiply. So the top stays sine x over cosine of x. Now it's times and flip this. Cosine of x over sine squared x. So this and this will cancel. And one of these will cancel with me. So I'm left with 1 over sine x. And the reciprocal of sine x is cosecant of x. And so we never want to leave a fraction if we don't have to. So that's why we flip it back up to cosecant. All right, so on this one right here, let's get a common denominator. So hold on, let's see. Secant is 1 over cosine. Yeah, so I'm just going to go ahead and multiply this for a common denominator first. So I'm going to do secant of u times cosine of u and multiply it to the bottom. And multiply this by a sine over a sine. So sine u times a sine u over cosine u times sine u. So now my bottoms are the same, so I can subtract my tops. So cosecant u times cosine. So remember secant is 1 over cosine. So really I have 1 over cosine times the cosine. Since they're reciprocals of each other, reciprocals always create a 1. So I end up with 1 minus, and that's sine squared of u over sine u cosine of u. 1 minus sine squared, hopefully you're catching on by now. 1 minus sine squared would end up being the cosine squared here. So that becomes cosine squared of u over a sine u cosine of u. So one of these will cancel with that whole term on bottom. So I get cosine u over sine u. So that gives me cotangent of u. All right, on this one right here, I have a sine cubed and a sine cubed in both terms. So I'm just going to go ahead and factor that out. So that will make life a lot easier. If I do sine cubed, pull it out, I'm left with cosine squared of x minus 1. I see a sine cubed or a cosine cubed, so I know that's going to end up being a tangent cubed. So I'm just going to leave that for a second. And so let's see, it's cosecant squared minus 1. So you go to your paper here, and you have cosecant squared of x. If I minus my 1, what's left is the cotangent squared. So I have sine cubed x, so that's going to become cotangent squared of x. Oopsie, over cosine cubed of x. So remember I said sine over cosine. Since it's all multiplication, I can rewrite that. So that's going to give me a tangent cubed of x times cotangent squared of x. So tangent cubed x, and so this is really the same thing as like a tangent squared of x times a tangent of x. These are reciprocals of each other. That tangent squared and that cotangent squared are reciprocals. So I got tangent x on that one. So onto the back now, we're going to be proving these identities. So what that means is that we only work one side, and you are done when you get cosecant x. So it's like I'm telling you the answer, but you have to get to that answer on your own. You cannot touch the other side. So if you'd like to start on the right side, you can and try to get the left. Most of the time, it's easier to work left to right. So This right here is the same as 1 over sine of x. And then, so times cosine squared of x. And then this is just a sine x over 1. So get a common denominator, multiply this by your sine over your sine. So you'd end up with cosine squared of x, because you multiply fractions straight across. And this becomes sine squared over sine. Your bottoms are the same, so you add your tops. So we get cosine squared of x plus sine squared of x. And then this becomes 1 by using the property right here. Sine squared plus cosine squared equals 1. So I end up with 1 over sine of x. 1 over sine of x, the reciprocal is cosecant of x. So I got my answer right. Yay. Okay, so on this one right here, it might be easier for you to work the right side of this than it is the left side. So I know how to do it from the left side over, but it's a little trick that I've used many a times in there with sine squared, and I would change it to 1 minus cosine squared, and then I can split it up, and bam, the answer happens for us. So I'll show you that real quick. That's what I would do, but you might not think of this. So sine squared I know is the same thing as 1 minus cosine squared of x. And then I have a cosine, oh, they're y's, over y. And when there's only one thing on bottom, I could split these up. So I could get 1 over cosine of y minus cosine squared of y over cosine of y. This becomes secant of y. This becomes cosine of y, and you're done. Right. If you did not think of that, though, you could have worked your right side, meaning I would first change these to sines and cosines. So this is another way to do it. So 1 over cosine of y minus cosine of y over 1. Get a common denominator here. So essentially, I'm going reverse direction of the other one. So this would become cosine squared of y over cosine of y. Bottoms are the same, so you would subtract your tops. And then 1 minus cosine squared is your sine squared. And you still end up with the other answer there. So either way you prove it, this is working one way and that's working the other way there. Okay, on this right here, when I multiply it in, I'm going to go ahead and multiply in my tangent because that's the way my brain works instead of getting a common denominator. So I'm going to multiply that in. So you'd end up with like a tangent x secant x over tangent x minus a tangent squared of x over a secant of x. So these tangents are actually going to cancel for me right there. So I just need to get a common denominator by multiplying this by a secant x over a secant of x. So I get secant squared of x over secant x minus a tangent squared x over secant x. So secant squared minus tangent squared is one of our properties. Secant squared, if I minus over my tangent squared, I end up getting 1. So I get 1 over my secant x, and then that's the reciprocal of cosine of x. So we're done. I like to put check marks when I'm done because that makes me feel good. All right here. So this one right here is going to be nearly impossible for you to work the right side to get to the left side. You would need lots of tricks to get to it. So let's just go ahead and work the right side here. So I see there's a cosecant squared in both of those. So I'm going to go ahead and factor that out. And then I notice 1 minus sine squared, that's one of our rules. So if I do 1 and I minus my sine squared over, I'm left with cosine squared. So I'm going to end up with cosecant squared of x times cosine squared of x. And then cosecant squared is sine, so 1 over sine squared of x times cosine squared of x. So that's the same thing as cosine squared of x over sine squared of x. And cosine over sine is cotangent. So I get cotangent squared of x. So we're done. Yay. So right here, the first thing you need to do is to get rid of all the negative angles. So you have to know even and odd stuff. So tangent of a negative is negative. So I have negative tangent of x. Sine is also a negative. So negative sine of x plus, and that's just going to be cosine of x. So now I'm going to change these to sines and cosines. So I'm going to have sine of x over cosine of x times, that's like a times a positive, sine of x plus cosine of x. So we need a common denominator, so multiply this side by a cosine over a cosine. So I end up with sine squared of x over cosine of x plus cosine squared of x over cosine of x. The bottoms are the same, so you can now subtract the tops. Or add the tops, sorry. So that becomes sine squared plus cosine squared over cosine of x. So we get 1 over cosine of x. And then that's the reciprocal of secant. And you should keep them as u's. I'm lazy. I shouldn't be changing the variables like that. It's bad practice. All right, and then on our last one right here, so this one also would require a trick on the left side here. So let's go ahead and just work the right side out. So the right side, I'm going to change everything to sines and cosines. So the first thing I have on top is 1 over cosine of u plus 1 over sine of u. And this is going to be sine of u over cosine of u plus cosine of u over sine. So what we need to do is common denominators. So I multiply this by sine u's. This one's going to get the cosine of u's on top and bottom. This is the sine. This is going to be the cosine. So on my top fraction now, I have a sine of u over sine u cosine u plus cosine u sine u cosine u. So on top, that's just going to give me sine u plus cosine of u over that bottom. On bottom here, I get sine squared of u with the same bottom. This is cosine squared. So that's sine squared plus cosine squared. Sine squared plus cosine squared is a 1. So now I can flip this and multiply it to the top. So top is a sine u plus cosine of u over sine u times cosine of u. Flip the bottom and multiply. So this becomes sine u cosine of u over 1. These are the same terms, so they cancel. So then I end up with a sine u plus cosine of u, and that's what I was trying to get to.